Hi, this is a lecture video for week number one, demonstrating how to do the assignment for chapter two in the textbook. Let me show you where this is located, and so it should be like right here. So I'm sharing with you the week two material, so this is the portion that you need to be doing, okay? So if you download the lesson plan from here, this is what you see. And if you go down here, I made a copy of from your textbook on what you need to be doing. Okay, so the first question is, how do you do, says answer the question 29, 30, whatever, from chapter, page 50, convert binary, 29 is a converting from binary to hex. So it says convert these numbers, which is in binary, convert them into hex. So what you want to do is to look at the, let's see, if you go to, let me pause for a second. Okay, if you go back to the week two material, and let's see here. So here is the binary conversion notes. If you, it's a PDF file. If you download it, I think it'll bring it up. So you will see this. So I'm going to bring it up on a separate here and show you how to do it. Okay, so let me put it here a little bit like this so you can see both. So this is asking you to convert binary number 101010001. I talk a little bit more about the binary numbers and stuff like that a little bit later, but I just want to show you directly how to do the assignment itself. All right. So I think maybe one way they can do is to use a binary converter program. So let me pause here for a sec. So maybe put this guy here a little bit. If you you can search online for different online number converters, but I think I gave you a link down here somewhere. Just go down here. So there is a online number converter. If you click on this guy, there are actually two of them, right? So if you click on the first one, this is what you get. And so if you want to convert this number right here, 101010001, the way this website works is you just put in the value of whichever you want to convert, and it'll fill in the other stuff. So if you type in 101010001, right? So as you are typing, it converts that number, this number, into the other number system. So for the hexadecimal, it's an A9. All right, so you can do that. Now you may wonder, well, how does it actually work, right? So that's when this guy comes in. So hex number, and now is probably the good time to show you how those number systems actually look like. And so let me just kind of show this here first. But here's the number 1010. You write the number down, and the way you go from binary to hex is you group the digits by 4. Okay, and the reason why you are grouping by 4 is because you will see that hex is a made up of 4 binary bits. A little bit later you can see. But anyway, so you group them by 4, and if there is not enough complete set of 4, you always start from the right side. So you start with your 1, 2, 3, 4, and you group that 4, and then you group this guy by 4, and you, in this case, you have a good complete set. But anyway, so whatever you get, then you convert that number to a decimal first. So right now you don't know how to convert this to a decimal either, but which I'll show you in a second. But anyway, so if you convert this 1001, it'll turn out to be 9. So if you do 1009, decimal it is 9, right? So that's a 9. And then you do 1010, and then you do 1010, and for the hex it's A. Well, so, but I said to do a decimal first, it becomes 10, but hex is a number that goes 1 through 9, and then instead of having 2 digits, it goes into letters. So 10 is actually letter A, and 11 is a B, and kind of like that. So the answer to this question is A9. You can follow a similar format here to answer the rest of the questions. Okay. Let me kind of pause here and then show you the number, like go down here, which may be helpful now. So like this one here, let me make it a little bit bigger so you can see. So a decimal number is a number system where you have one digit that goes from 0 to 9. And when it repeats from 0 to 9 again and again and again. But once you use it all up and you're repeating the second time, to indicate this is repeating again, you put a 1 in the next left side. So 10 means that the whole cycle has gone through once, and then you're starting over again. And when you get to the 9, there's no more number to be used because we only have 0 to 9. It repeats again with a 0, but you add 1 to the 1 on the left by saying I went over once, now I'm going over twice. And the hexadecimal is similar, but it uses a 15. So you have like 0 through 9, so that's a 10, and then, well, in decimal, right? But instead of stopping, it starts to use a letter. So there's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters that start from 0 to 9, 11, 12, 13, 14, 15, 16, right? So there are 16 digits that we are going to use. But the value of this 0 is a 0, so even though it counts as a number, the value is 0. So this is a 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a 10, 11, 12, 13, 14, 15. The value of F is 15. And then it'll stop because hexadecimal means 16. And then it repeats again from 0. But once again, because it is not the first time it's using, but a repetition of the cycle, you put 1 on the left. And then you kind of do the same thing over. Oct is 8, using 3 binary bits. But let's do the binary first. The binary, again, starts with the binary just means 2. There are 2 characters, a 0 and a 1. So you start with a 0, which has a value of 0, counts to 1 as a value of 1. But then you're done, right? So you have to repeat again. So it's a 0. But then to indicate that it is not the actual 0, but a repeated 0, you put a 1 onto the left. So it becomes a 1, 0, right? And then you increase it to next 1, and you're done, right? So it'll be 0, 1, 1, 0, 1, 1. Now it becomes a 0 because that you have to start over. And you have to add 1 to the 1 that's already there, which is 2, but you don't have 2 in binary. So this becomes a 1 to the left, and then you have to start over on the left side as well. So it's a little bit of a nuisance, but the idea is the same. So anyway, so here's the nice table that you can refer to. But anyway, let's go over to the second question in your book. It says, convert the decimal to binary. Okay, this is a little tedious, but there's a good trick to this. And so what you do is convert the this binary here. So it says convert 45 to binary, right? 45 in decimal. So if you want to use a calculator, let's see here. Is that what that is? No, not that one. But maybe this one. That one. Here we go. So let's say 45. Let's clear the whole thing out and put binary decimal for 45. It gives you 101101. Well, how to get there? Well, let's take a look, right? So let's put this guy over this way. So what you do is you put, and the notation that we're using is going from 45 parentheses decimal 10. So this is the base that we're, a small number indicates the base of this number system, which is a decimal. And then we want to go to 2, which is binary. The way you do that is you put the number down, and then you put like a division, upside down division, because we're going to divide number 45 by 2. Why 2? Because we're going to a binary. But we don't divide it traditionally. We're going to divide them down. So you divide 45 by 2. You get 22 goes in there with the remaining 1, and you keep dividing. And whatever you get, 22, the 11 goes in there with a remainder of 0. You got to write down the remainders, whether it is 1 or 0. And then 11 divided by 2, you get a 5 with a remainder of 1. You do it again, 2 goes in 2 times with a remainder of 1 for 5. And then 2 goes in there once. Exactly. And there's no remainder or remainder of 0. So you do it whatever decimal number you get, you keep dividing down with the number 2, and make sure you write down the decimal of the remainder. And the trick is you collect the remainders from the bottom up. Okay, so you go 10 1101, and that's what you write, 10 1101 from the bottom up, from the left to right, and that's the answer. So if you bring this back here, right? So let me bring this guy right here a little bit. And as you can see, decimal 45 is a 101101, which is like right there. Okay, so this should be pretty straightforward on how to do that. All right, so you can do the same thing for the other ones. And for decimal to hex, right? So here's a decimal to hex. What you do is, let me bring this guy up a little bit here. To go from decimal to hex, what you do, let's see, give me a second, pause for a second. So this one, I guess I didn't write it up here. Maybe I'll do a little more writing on here. But basically the idea is do it in 2 steps. You convert the decimal to binary first, and then we already know how to convert binary to hex because I already showed you up here, right? You grouped it by 2. But so decimal numbers, you can also use this one here. Let's say 1066, right? So let's get rid of all this here. 1066. It converts to binary. And you group these guys by 4, right? Like that, and then like that, and then like that. And it should come out to be, so here, if you get these 4, the binary here, the value of this one is, here's a 1, 2, 4, 8. Let me show you why that is the case. So here's the binary. The place value. So let me see, maybe this is a little bit better. So if you have a binary number like this, 1001, what is it, right? What you do is you put in the, so if this is the binary number that's given to you, then what you do is you put a value of this binary digits by starting 1 and doubling it to the left. So and it starts with 1, and you put 2, and then double of that is 4, and then this one is double of that is 8, and then 16, 32, and kind of goes on. And then the second part you do is to collect the value of these digit places wherever there is a 1, because 0 doesn't count, right? So 1 has a value of 1, so it'll be 1. This one has a value of 8, right? So 8 plus 1 will be 9. So 1, 0, 0, 1 is a 9. So you can look at that. And so if you want to verify, let's see if we go down here. Binary of 9, this guy right here that we were looking at, right? 1001, 1001, that's a 9 in decimal, right? But if it is a 10, 1010, it's an A in hex, but 10 in decimal, right? So anyway, so you want to convert the decimal to a binary first, and then grab 4 bits at a time to get the hex. So if we did over here, maybe it's not this one. So, but anyways, so this is a 10, which is A in hex. And then you grab the next 4. This is a 1, 2, so that's why you got a 2. And then you grab the next 4. There's only 3, so you won't only grab 3 of them. This is 1, 2, and 8. I mean 1, 2, 4, right? So there's a 4, 4, 2, 8. That's what this binary is in hex. But you will need to convert first from decimal to binary, and then grab 4 bits at a time. I'll update the sheet here a little bit so that you can see how that's done. But anyway, so hopefully that makes sense. This one is for how to go from hex to binary, and I know I didn't ask you that, but the way you do them is, let's say 2C7 is in hex. How do you go to the binary? Well, this is really easy because all you do is take one character at a time and then expand using 4 bits in binary. So 7 is a 110 because it is a 1, 2, 4. That's a 4 plus 2 plus 1 is a 7, and that's what you get. And then C, you get it's a 1, 2, 4, 8. It'll be 12. As you can see, this is a value of 2, right? So you're basically expanding it out to using 4 bits of binary. And 2 is a, this is a 1, this is a 2, so it'll be 1, 0. In putting this value into a binary, you don't have to include the leading zeros. It'll be an optional one. But anyway, that's how you do the assignment for this textbook. Okay, so hopefully that kind of shows you how to do it. If you have any questions, you can feel free to email me. Let me see if there's some other videos that might be useful. Hold on. So let's see, here's some other binary number hexadecimal converting, and then I showed you that. This one is kind of nice because there are other conversions you can use for, especially for the network. I think that's pretty much it. So this ends the recording for how to do your textbook assignments. I'll see you on the next one.